Okay, so from variance, we get to covariance. Okay, and it works very similar in the calculation. And covariance, we'd love to really would be what we'd love to understand. It becomes a little bit confusing for a reason, and we'll discuss that. But it works really well in describing how things move together. So, or how they're generally above or below the mean together. Okay, so what this is saying is for every sample of x, we're going to minus it from the average of x. For every sample of y, we're going to manage it minus it from the average of y. And there's no square here because we're times x times y, okay? And so it kind of cancels each other out. Then the negatives would cancel each other out and the positives would cancel each other out. This really gives us a sense of how things move together generally, how above or below the average they are together, okay? So this is a really good sense of what we would want to do. The problem with this is its covariance is really affected by the scale of our units and really the unit of measurement. Okay, so it's one of those things that if you have, let's say, bananas times kilometers, you have a covariance of 100 banana oranges. It's kind of, it becomes a little bit confusing. You could maybe think through that. It's unfortunately not super relative, but also because the scale of the unit of measurements are very different, it becomes very hard to compare covariance between any this data set and another data set. So you could say, oh, my features have a really high covariance. But how do I know what that number is? It really depends on the scale. So covariance is also, again, then very sensitive to, say, the scale of measurement. And it becomes a little bit less relatable and it requires a little bit more explanation if you were to communicate these results.